Welcome to the Explainer. So, if you've been tracking the AI space lately, you know we're moving way beyond simple large language models. We are stepping right into a completely new paradigm, agentic workflows. Now, AI agent is absolutely the defining buzzword right now, right? But we really need to look past all that marketing hype to understand the actual mechanics at play. So today, we're going to decode this massive buzzword without any of the stressful jargon. We're breaking down the architecture of AI agents to explore how these systems transition from just generating text to actually operating in a continuous loop of understanding, perceiving, thinking, and acting. We're going to decode how this tech bridges that gap between language comprehension and autonomous execution, because it is fundamentally changing how we interact with software. Let's get right into it.
Okay, let's dive into this. What actually is an AI agent? And honestly, more importantly, where is the boundary between an agent and the standard AI chatbots we've all been using for the past couple of years? It is completely valid to be confused by this right now. It's so easy to look at the landscape and see blurred lines, especially since tech companies constantly throw these terms around interchangeably in their marketing. I mean, a lot of standard conversational models are being rebranded as agents just because they have a web search plugin attached. But I promise you a clear, tangible answer to this mystery in just a few minutes. True agents represent a totally distinct structural evolution. In this explainer, we're unpacking the underlying structural differences. We'll see how agents are engineered not just to parse prompts, but to manage state, orchestrate tools, and navigate complex decision trees autonomously.
To really grasp this architectural shift, we first need to look at the frustrating limitations of standard chatbots. Think about the underlying mechanics of your typical chatbot experience. You put in a prompt, it processes it, and it gives you a response. Now, don't get me wrong, it's an incredibly powerful engine, essentially a highly advanced, super smart encyclopedia. But fundamentally, it only talks. It relies entirely on continuous human prompting to move forward, and crucially, it has absolutely no access to an execution environment. Say you want a chatbot to handle a complex task, like migrating data between two cloud services or booking a multi-leg flight. It can tell you exactly how to do it. It can give you the exact code or the API endpoints, but it stops there. The bottleneck? Well, it's you. You are the one who is stuck doing all the manual clicking, jumping into the terminal or the web browser, and actually executing every sequential step yourself.
Let's anchor this with a physical kitchen metaphor before we get any deeper into the tech stack. Think of a standard microwave. It operates on a principle of purely linear execution. You give it one rigid instruction, it performs exactly one step, heating your food, and then it just stops. That stateless system design is exactly how traditional computer programs and frankly most standard chatbots operate. One input equals one fixed output. The system just waits, passively in standby mode, until you, the human operator, intervene again. For a really long time in AI development, bridging this massive gap between a language model's ability to reason and its ability to actually trigger independent software execution was the missing link. We had the brain, but it had literally no hands to interact with the digital world.
Now, what's really interesting about this slide is how it perfectly illustrates a total paradigm shift. Imagine the equivalent of hiring a human chef. When you hire a professional, you don't micromanage them with 100 linear instructions, right? You provide a single overarching objective. Make dinner for 4. The chef then totally takes over the execution. Let's map this directly to system architecture. When the chef checks the fridge, that's autonomous data retrieval. When they realize they're out of ingredients and run to the store, that's external tool use and API calling. And most importantly, when they taste the sauce and adjust the seasoning, they are running an autonomous feedback loop. You gave them one goal, and they dynamically calculated the route and autonomously executed all the multi-step processes to actually get it done.
And this is the exact architectural framework of an AI agent. Just like the chef, we are moving from a system of one instruction equals one step to one goal equals many autonomous steps. When you deploy an agent, you're giving a large language model an overarching objective and a whole toolkit of external tools. The agent uses iterative reasoning. You'll often hear this called a chain of thought to break that massive goal down into manageable subtasks. It independently plans the steps, takes action, and crucially, it checks its own work. If it hits an error or an API timeout, it doesn't just crash and wait for you to come fix it. It uses self-correction. It actually reads its own error logs, realizes its initial strategy failed, recalculates a brand new approach entirely without you, and keeps going until the job is completely done.
Let's bring this metaphor back to reality for a second and look at 3 concrete, real-world examples to prove this isn't just theoretical technology. This is already disrupting production environments. Take software engineering. We're seeing sophisticated agents scoring incredibly well on industry benchmarks. These aren't just advanced autocomplete tools. These are agents that can receive a GitHub issue, autonomously spin up a secure sandbox, write the code, run unit tests, and, if the tests fail, read the error logs to continuously patch the code until it actually compiles and fixes the issue. Or think about everyday tasks, finding, comparing, and booking flights entirely on its own. Over in data analytics, agents can crawl fragmented databases, synthesize the raw data, and write up comprehensive intelligence reports. In all these cases, the agent handles the entire life cycle, doing all the intermediate steps that would normally take hours of human time.
And this brilliantly illustrates a crucial piece of terminology you are going to encounter heavily in research papers and deployment logs: agentic. Let's decode this industry jargon real quick. If the agent is the worker, agentic is simply the adjective describing its active, independent working style. But it's really important to understand that agentic isn't just a rigid binary switch, where a system is either purely an agent or purely not. Actually, scratch that. It's more like a spectrum of autonomy. On the lower end, you might have a language model that can use a single tool, like running a quick web search to verify a fact before it answers you. But on the high end of the spectrum, you have highly agentic frameworks that can manage complex multi-day, multi-step workflows. They coordinate with other specialized subagents, maintain long-term memory, and orchestrate massive back-end operations all by themselves.
If there is a core mnemonic, an ultimate takeaway I want you to remember from this explainer so you never forget the fundamental difference between the two systems, it is exactly this. Chatbots talk, while agents do. It is a deceptively simple framing, I know, but it perfectly encapsulates the massive shift in computing we are witnessing right now. We're moving AI from being a conversational novelty, a helpful oracle you just talk to in a chat interface, into a background utility layer that actively operates our digital infrastructure. In the very near future, the most powerful AI systems won't be the ones we sit and chat with. They'll be the invisible, agentic systems operating silently in the background, executing workflows, managing infrastructure, and seamlessly doing all the heavy computational lifting without us having to manage every single click and keystroke.
As we wrap up this deep dive into agent architecture, I want to leave you with a provocative thought focused on your own tech stack. Now that you know the difference, now that you understand the autonomous feedback loops, the tool orchestration, and how these systems actually work, what daily tasks or complex professional workflows are you ready to hand over to an agent first? We aren't just talking about drafting emails anymore, guys. Think about your data pipelines, software testing, or complex research syntheses. Which of those intensive processes is ripe for agentic automation? Remember, this technology is really easy to grasp when it's explained simply, and understanding it structurally is the very first step to leveraging it effectively. Thank you so much for joining me for this explainer.